And we're live.
Okay.
All right. So I'm gonna go back to my document here, the preparation assignment.
Okay.
I'm gonna go ahead and start reading the first one.
Okay.
So use the information in the reading assignment and to complete these questions. Number
Okay.
one, what is the sampling distribution? And what I was reading, it's that the sampling distribution is a set of all possible results or observation or sample means from a population, and that we will only or we usually see the results for just one sample and not all of them,
Mm-hmm.
but there are many, so that's the sampling distribution.
Okay. Great. Okay. Number two, what is the shape of the sampling distribution of the sample mean when the data are normally distributed? Well, here it says that the data are normally distributed, so the shape is normal.
Right. Number three, what is the shape of the distribution of sample means when the data are not normally distributed, but the sample size is large? And as well, it will be approximately normal due to the theorem of large
Oh,
numbers.
yeah. Okay. Okay. Number four, how does the shape of the distribution of the sample means change when the sample size is increased? Well, the sampling distribution more closely approaches to a normal distribution when the sample size is increased and the standard deviation decreases.
Right. Number five, what is the difference between the central limit theorem and the law of large numbers? Okay, so the central limit theorem states that if the sample size is large, the sample mean will be approximately normal or normally distributed, and the law of large numbers states that as the sample size increases, the standard deviation will get smaller.
Okay. And number six, when is sample mean? Right. X is sample mean, right? When is sample mean normally distributed? Well, X bar will be normally distributed, as we said in question number two, if the data drawn from a normal population is the shape is normal, right? If it is normally distributed, or if the sample size is sufficiently large.
Right.
Okay.
Okay. So the next one, number seven, is it? Yeah.
Yeah.
It says, well, we first had to cut out the squares of the page, which are shown on the second page of the preparation assignment. We had to
Mm-hmm.
select five at random, five of the
Mm-hmm.
squares, and compute the sample mean. We also had to use the random.org and generate five random integers between 1 and 30, and use the salaries from the five squares corresponding to your five random integers to compute the sample mean.
Okay.
So
And what?
I went ahead and checked that out, but I don't have my spreadsheet here in this computer. So what were your numbers?
Okay. My numbers were um, number four, which is 47,800. Number 17, which is the amount of 39,600. Number 20, which is the amount of 37,900. Number 29, 45,000, and number 6, which is 45,000. So my mean was, I used the random.org to generate these numbers,
Right.
and I got is 43,060.
Okay. Yeah, I already did this assignment, but I don't know. I don't have my spreadsheet here with me, so. Then it says your mark depends. Well, that's for the next question, which is this graph illustrates the distribution of sample means. There are 142,506 possible combinations of the 30 salaries drawn 5 at a time. This graph represents the distribution of all possible means. Make a mark on the horizontal axis to indicate the value of your sample mean from part A.
Okay,
So
my sample. Okay.
Yep.
My sample mean was 43,060. So to answer question, well, the next question is that my sample mean appears to be not unusual because it is between the range of 2 points. Do you remember the rule 68, 95, 99.7?
Yes.
Yeah, that's why
it's right. Right. Yeah, mine was, I think, if I remember correctly, mine was 46,090.
Okay.
And it was also not unusual also.
Okay.
Okay. What about C?
Yeah, exactly. That my sample mean was not unusual.
All right. So sorry, D.
Oh, D. Well, we had to compare our mean, so we already did. So we did observe, yeah, other means. Well, your mean was different than mine, so there are many means that could have occurred.
Right.
There are possible
Which is the
sample
sample distribution, right? Sampling distribution.
Okay.
Okay.
And next one, it says the cat. Yes, Julio? Hello?
Can you hear me?
Oh, yes.
Oh, sorry.
Okay, you want me to read question A?
Yes, please.
Okay. The graduate management admission test is used as an admission criterion in many Masters of Business Administration MBA programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a sample random sample for n equals, well, the sample of 10 students taking the GMAT. What is the shape of the distribution of the sample mean for all such samples? Well, I got that this shape is normally distributed because it says the scores on the GMAT are normally distributed. So
Right. Yeah, I also got that from this exercise.
okay.
B, it says, how do you know that the distribution of the sample mean has this shape? One of the rules says that if the parent population is normally distributed, then the mean will also be.
Yeah, and because it says that the question itself says that the scores are normally distributed.
Right.
Okay.
C, what is the mean of the sampling distribution of sample mean scores for all such samples?
Well, that's 529.
Yeah, 529. Was pretty simple.
Yeah.
What is the standard deviation of the distribution of sample mean scores for all such samples?
Does that?
On that one is 35.73.
Oh yeah, I got the same one.
Okay.
Oh, that's
So
all?
I think that it was a pretty straightforward topic, so it was easier.
Yes.
Okay, so I'm gonna stop broadcasting.
Okay. Great.
Okay.